Hey guys, welcome to Pep Coding. Today I'm going to teach you a very interesting question, coloring border. This is first question of the graph of level up. Okay. So please pay attention. So basically we would be given a grid and we would be given a particular location. Suppose this is my particular location and what I basically need to do is color all its border. What do we mean by border? It's a graph question. So assume that all of these have four edges. Okay. In four directions, up, down, right, left, they are connected. Assume that. We can assume that we have a graph like this. If we have given array, we can always assume it as a graph. Suppose this is my graph here. Okay, it is connected. So what they are saying is that in the four direction, check in the four direction for all the colors that are same as my location color. Suppose my location color is 2 here, and I'll check if it is 2. In that case I need to color. This is 2, I need to color. This is 2, I need to color. 2 2 2, I need to color all those while traversing. Okay, but one catch is there. If all the four direction gives me 2, then I won't color. See, for this case, 1 2 3 4, all of its edges are 2, so I won't color this one. I'll go to this, I'll color this because this one is this does not have all the four direction as 2. I'll color this, I'll color this, then I'll traverse in, I'll put the DFS and traverse for all the twos which are connected to each other, directly connected or indirectly. So this one is not directly connected because here is a gap. Here it's 3. If I put the connection, then here comes another color. So when I take the path, then it should have all its value same. Okay, all of them should be 2, but this won't be colored because this has four direction. All of them are not 2, so in this case I won't color. Okay, for this question we need to understand one thing, that there is a special case. There are basically two special cases that we need to take care of. See, this two and this two are not connected, so don't go to this two saying that these are diagonally connected, so they must be connected, so let me color this two. No, we can't color this. Okay, and one more thing. Suppose my color is 3 that I need to color. I need to color all these 8 elements, as 3. And when I travel, then here comes 3. So I don't need to go there. Okay, remember this for any approach, for any logic that you are thinking of or coding. Remember these two cases, diagonal edge and any of its connected edge is as of same color. So if you say that it is of 3, let's color traverse here, then traverse here, here, everywhere, which are like from here traverse, you start traversing there, or from here you start traversing to these threes. So we can't do that. Okay, these two cases are something that we need to remember. Now let's come to the solution. So see guys, we are here. It is clear that if I put a DFS and traverse in all the four direction, and put a condition that I am traversing to only those edges which have a similar value of mine, then there can be one thing that I take the count that how many similar values I have in my edges. If it comes to 4, then I simply won't color it, else I'll color it. So there would be something work of DFS that I need to traverse through all the connected elements. Okay. One more thing that I'll have to keep a count, that for every edge, if all the four edges return me same value, in that case I won't be able to color myself. So I will have to take a count also. Okay, so it's simple. So whenever I come, let's start the traversal. I'll dry run for you. I'll do a dry run and I'll explain you the logic. When we are at the particular location, first of all mark it as negative. I'll mark it as -2 that I have already visited. I won't take another visited array. I optimize my space and mark it -2 because I have been provided in the constraints that all the values in my array are positive. Okay, so I'll mark it negative. Then I'll make my call upward towards left. These calls won't be made because the colors are different. I'll have a condition. If they are different, then I won't make call. Okay, then I'll make here. It's same, so my count would be incremented. So it would be 1. I'll make a call. Then I'll make upward call. Can't make. Left call. I can't go there. It's visited, but its color is same, so I'll increase my count. I'll show you in the code that how it will be managed, but somehow we'll manage. If the color is same, I'll increase the count. Then I'll go to right. Color is same. Count is incremented to 2. I move towards right. I move towards upward. Can't go. Different color. Left, it is already visited. Mark it visited first. Okay. Count would be 1. I'll make this call. Then I can't go. I'll make a downward call. Okay. Count would be incremented to 2. I'll make this -2. Upward call. Count incremented to 1. Left call. Count incremented to 2. Here, I'll make upward call. Count incremented to 1. Left call. Count incremented to 2. Upward call. Count incremented to 1. Left call. Can't make. Right call. Count incremented to 2. Down call. Count incremented to 3. Up call. Count 1. Left can't make. Right count equals 2. Up count equals 1. Left count equals 2. Right count equals 3. Up count 1. Left count 2. These are visited. Can't go there. But I'll get the count. Okay. So count equals 2 now. Then right can't go. Down can't go. So count is 2. Since my count is not 4, so I need to color this. If I need to color this, I won't change its number from -2 to 2. I won't change it to 2 again. I won't mark it unvisited. I'll keep it visited, and later on I'll color them. Okay, I'll see what I have to do for negative. I'll come here. One call was pending downwards. I'll make the call. I can't make it, so check the count. It's 3, so I won't convert it back to 2. Come here. I'll have one call pending downwards. I'll make the call. Can't make, so count is 2, not equal to 4. I won't convert it. I'll come here. All 4 calls are made. Count is 3. Won't convert. Here, when I come here, my count was 2. 2 calls were remaining. Okay. I'll make this right call. It is already visited. So count equals 3. Color was same. Downward call. Visited, but count is 4. Incremented. So since count is 4, I'll convert this from -2 to 2 back. Now I'll backtrack here. My calls were remaining. Right call, I can't make. Left call, yes. Count will be incremented, but I won't go there because it is already marked visited. And since count is 3 not equal to 4, I'll simply backtrack without changing the value. Here, all 4 calls were made. Okay, so I won't change because count is 2. I'll backtrack here. One call was remaining downward. My count would be now 3. Okay, check the count, it's 3. So we don't need to update its value to back to 2. Come here, 2 calls were remaining. Okay, first of all, only one call was remaining, not 2. I'll check the downward, can't go, it is already marked visited, but since it's 2, so I'll simply check for, I'll update the count to 2, check for count, it's 2 not 4, then I won't update. Now see, these all have a negative count and this one has a positive count. In complete array, only these 8 2's will have a negative count, else every element will have a positive. So I'll simply traverse in my complete array, in my complete grid, and check for these negative numbers. Whenever I'll find these negative number, I'll convert it into color. I'll color them. Suppose my color was 3, so I'll put all of these values as 3. All these 3, 4, 5, 6, 7, 8. These 8 values to 3. Okay, I hope the logic is clear to you. The approach is clear. If you want, you can code it yourself. Else you can see my code. Let's code this. So let's start the code. So first of all, I'll call my DFS function, which will give me the array with all its value negative that need to be colored. Okay, I don't know how it will do, but it will do somehow. So I'll pass my array, my current location, row call, and my color. So the color, what color would be? The color that was given in input? No. The color would be the color of current position. So it would be array of row all. Yeah. So now what? When this work is done, then I'll simply run my loop. Okay. I'll run the loop in the array. I'll traverse my complete array, and finally I'll check if the value of the current element is negative. If it's negative, I'll color it. Okay. So array 0. Why I'm using 0? Because it can be a rectangular matrix also. J plus plus if array of ij is less than 0, then array of ij is equal to the color that was given in input. I'll color it. Simply write return at the end. The writing of return is not compulsory, but make it a habit. If the function is of int type or something return type, then it must have return, and generally we forgot to write return at the end, so make it a habit. Now for using DFS, I have two options. Either I make 4 calls, or I'll simply make a direction array and in the for loop make the calls. So I'll prefer for loop because I'm a lazy person and I don't like writing too much. So let's make the direction array. So all the 4 directions, I need to add them. 1 0 0 1. It doesn't matter in which order you call the DFS, because it hardly matters, because we don't need to print any path or something. It's just that you print all the direction. You just traverse in all the direction. So in any order you can put your direction in direction array. It's up to you. Just remember all the directions must be there. Okay, so these are the directions. Now simply start void DFS. So this will have same input as my coloring border. But let's change the variable name of color, CLR. This will help us to understand that we are using different color. That was the color of given position. So first of all, mark the that position visited. So array of row call is minus of color. You could also write minus of array row call, but it is same thing because the call would only be made when we have the color present. So minus of color will also work. Now take a count that we'll have to check. If it is equal to 4, if all these edges have same color, then we don't need to work there. So for that, take a count. Now run a for loop 4 times because we need to recursively make 4 calls. Make new row and column. New row and column because we need to make 4 calls, so there will be every time new row and new column. So row plus direction of I0. Column would be direction of I1. That's it. Name is C. Now if R is less than 0 or C is less than 0 or R is greater than equal to array dot size or C is greater than equal to array 0 dot size. Okay. In this case, DFS won't work, so I'll simply put continue. One more thing, we need to check that if the call that I'm going to make, the edge is of same color or not. Now you would say that we need to check this array of R C not equals color, then also continue. Yeah, you are right, but here's a catch. Guys, I'm not putting DFS right away. First, you remember the case that the edge that we were going to see was already visited, but we still updated the count. because if the color is there, then count must also be there, na? So that's why I'll simply use math.abs, the absolute function. Okay. And later on, before making DFS, I'll check if it's positive or not. Only that in that case, I'll make call if it's positive. So in these case, we will simply continue. If this is not there, then either the array is not visited, but for sure the edge would be of same color. So count would be incremented. And if it is not visited, that is array of R C is greater than 0, greater than equal to 0, then make the call. So DFS array would be as it is, new position and color would be same, because we need to always check for that color only. Okay, now what? Now out of the for loop, if my count is 4, then I need to unvisit it. That is, I need to make it positive. So if count equals 4, array of row call, not RC, row call. Why row call? Because I'm not making call to edges. I'm checking for the original position from which DFS was started, and that was row call. Equal to color. Change it to color. Change it to positive, and finally, my usual habit is to write return, so I'll write it. Let's try to run this code for this input. I'm taking input myself, and I'll run it. See, I'm giving the input 113. That is this point. So all these two would be colored. Let's see. Some little bit of error. Line 4 only.